Well, now we're covering Chapter 10 in your textbook, Managing Risk in Projects. An alternate title for this is Replacement for Ambien. And if you can't find your Drucker book, Essential Drucker, which you read 2 chapters of, which will put you right out at night, and it's not habit forming, then open up Chapter 10, Managing Risk in Projects. That's a good one. Now, it can be interesting because with projects, you got 2 potential things. You've got what's the possibility that this risk will occur, and then what's the impact. So if you were on a side street and you were going to pull out on a major street, depending on the time of day and the workflow, the likelihood, let's say you've got a traffic light, and you've decided I don't like to stop at traffic lights. So without looking either way, you decided on a red light to pull out into the street. What's the likelihood of you being T-boned from the side, being nailed by a scooter or a moped or a car or a truck? So there's likelihood that it will occur, percentage. 100% means 1, and let's say 10% is 0.1. And what's the likelihood you will die if that happens? What's the impact? And literally, the impact of your action. If you pull out and you have, it's in rush hour, the likelihood of it happening would be pretty great. You know, somebody would probably hit you if you just pulled out without looking during rush hour, but they probably wouldn't be going very fast, so your likelihood of injury or death would be much less than if it was likelihood in 3 o'clock in the morning and you did the same thing. You pulled out. The likelihood of somebody hitting you, probability not that great, but the impact would be greater because people would be faster. I was in a conference in Seattle once, and we were walking from one building to another, and there were a line of cones on the sidewalk, and it said, "Danger falling objects." Now, you could tell the theoreticians versus the engineers. The theoreticians would stop right before the cones, and you could see them thinking this. You could hear it in just all their body language. They said, "What's the likelihood of something falling and hitting me?" And they'd walk, the probability, they'd walk straight through it. And the engineers would walk up to it and they'd go, might be not likely, but what's the impact? And they would realize what, a wrench from 20 stories up would do to your head, and they walked around it. And it's interesting, just the different perspective of something. So the possibility that will not turn out as it planned. How much impact would something have on your project? So in any type of potential risk, it could be anything, some type of failure. You couldn't meet the performance requirements for schedule or budget, anything that stops your project or causes failure. What would you consider failure? You didn't meet time, cost, performance, whatever, by a predefined margin. So likelihood times the impact. Typically, you would use 1 being 100% and 0 being no effect, okay, for each one of those. Now, first thing you have to do is identify the risk, and then you have to decide how much will these risks affect the project. What's that again? You're going to make an estimate of risk. You're going to guess. So when somebody says it's a 30% chance of this happening, where does that 30% come from? Estimates, which are guesses. So you're going to assess the risk, estimate, and develop risk responses, what you think is going to work to mitigate or to lower the risk, and then you're going to track and control the risk. So you don't just make a list think what you're going to do and then just forget it. You have to track as you go along when these risks will apply. And you're going to have times when you don't know if it's going to affect you or not. That's what the contingency for the risk you haven't planned for. So risk management goes through each phase of the project. So identify, assess, plan response, and then track and control the risk. Might be external. What's an external risk? If you're building a house, the inspector may not get there on time and delays everything. It may have a weather related. You might have a power failure in your area. You've got a temporary service and you don't have generators or inverters to power. You don't have your cold fusion device to power your way through all the power failures. You have flooding. You have just any type of impact from tariffs, from bans of certain products. You might have, this product that you were using for insulation is suddenly banned by the government, or they've put a stop work order because this is not allowed in this country. Oh, you're using a different material, or the drywall you got from China had chemical ingredients in it that was banned from being installed. That's happened. So it could be anything that stops you or causes a risk. It might be so because the project or what you're doing is too complex. You don't have maturity, and the product, like your hoverboard that you have, catches fire when you charge it. That's an issue. It has low reliability. Ouch. So anything, market conditions, physical environment, labor, project priorities, people get upset because you're using a device that the public doesn't like. You have privacy issues with the software you're developing. Anything. Exchange rates are bad. So you think of analogy, make checklists, look at your work breakdown structure, process flow charts, and this is a risk checklist. So you go through and you look at high, medium, let's see. You might go to, let's see, here you go. High risk, medium risk, low risk for the likelihood and the impact. And then you make a chart. Red being high risk, moderate risk being yellow, blue being fine. For the different, you make a work breakdown structure and then lay out your risk that way. It's a way of doing it. You might have a process flow chart. So I'm looking at, I start something and I go through and I sort by side, and I've got, machine stamps postage, and I've got we've changed postage or changed the format on that. That could have stopped a program. It could have stopped that portion of mailing. Brainstorming, where you sit together in a group. Delphi, you get with experts. Cause and effect analysis, you might find, here's a cause and effect. You've got hardware people, functions, and money, and it causes products being delivered late. And then you lay out, here are the people, key staff. This is a Ishikawa fishbone diagram. Okay, cause and effect diagram. And it was developed by Juran or Ishikawa in Japan. And it's a way of assessing risk and looking at it. Risk consequence is simply probability times impact. Now, you could use the 0 to 1 on each one of these and multiply them to each other, and the risk consequence being much less. So if this was 0.2 and this this one was 50% risk, okay? Then you're looking at, is that right? Let's see, 10. What are we looking at? We're looking at, you just multiply one times the other. Now you can make this anything you want. Might be, you can set it up. Now it's easier, I find it easier just to keep it with one, being 100% likelihood, but you could have an interval relationship and have the composite list likelihood. And that's where you take the composite risk and you just add them up one after another and have your composite likelihood factor down here. So likelihood times impact, likelihood times impact, likelihood times impact, and you'll get a risk consequence on each one of those. Add up all of those. They should be under 0.3, which is the beginning of moderate risk. I've had students, and they were using the 1. They were using 1 as a basis of 100% likelihood their project would fail. And they came out and they did a composite risk, and it was 4.0. 400% chance their project would fail. Nah, you're not going to even start it. 0.4, I'm not sure I'd start it. 30% risk is the maximum you really ought to think of on a project before you'd go on with it. Right? So now, probability times impact. Now this one is setting this from 1 to 5, and that's fine as long as it's consistent throughout and you understand that 3 in this is a moderate risk. Anything above 3 is high risk. Anything above 3 is high risk. Okay, so this is moderate risk. Anything above it is high risk. So you can go through here and list the risk and multiply the likelihood times the impact. You can make a chart, likelihood times the impact, and then rate it low, medium, or high for the table, and look at the different tasks. You can make it as a table like this, and then you could take a risk register, and that's looking at the risk sources and the effect on the project on here, and you can multiply it out like that. Now, how do you lower the risk? Well, you transfer it. If you were planning a party and you were planning it outside, and how could you lower the risk? Well, weather. You might lower the risk by inviting your neighbors. If you are afraid they're going to complain about your loud music, invite them. Make sure, the speakers can't be heard 5 blocks away. You don't want the police to come, so you're going to check IDs, so you could lower your risk there if you're giving out alcoholic beverages. You could possibly get security there. If you're worried about other people coming into the area, you could lower your risk there. Think about all the things that could occur. You could get insurance. You could, if you need it. You could put up pavilions or tents to protect in case of weather, inclement weather. Vanderbilt had a graduation, and what they do during commencement, if it rains, they go to the Memorial Gym. They go to Ross Perot had his grandson who was going to graduate, and it rained the year that his grandson was going, and he'd come to hear him as he walked across the stage get presented with his diploma. Well, it rained, and one of the sheets that they had for the graduates was lost. the person that was in charge of that contingency plan to lower the risk during rain was fired on the spot. They have since reduced that because when Ross Perot got up and the grandson walked across the stage, they had lost that sheet. Ouch. Okay, he was a presidential candidate at one time, multimillionaire. That was a bad thing. Probably won't donate much to the school if that was the case. So one of the issues is to mitigate the loss or the danger, they had made electronic copies that are distributed during commencement to multiple areas, so they're not going to lose it during power failure or anything else. And they hired somebody that speaks 8 languages to record all the names of everyone graduating. So even if it's a Thai name with 10 syllables, they could pronounce the name of the student. So it's not some poor dean trying to pronounce some language that they're not familiar with, a name that they're not familiar with. So they reduce the risk that way. You can reduce risk by transferring it with insurance, with contracts. You could eliminate the sources of risk by just making sure you could micromanage. That's tough. You could reduce by getting the best workers or doing parallel things, incentives, reduced complexity. Those are good. Contingency plans. What if? You could accept the risk and do nothing. There's a whole section in your text and in the supplemental text for the PMP that cover risk, and you need to look through those. You definitely need to create a risk register and monitor what's happening through your project for not just for budgetary reasons, for time or schedule reasons with your buffers, but to monitor because risks change as the project goes along. Consequences, risk management, risk profiles. All you have to monitor. You might assign a risk officer. You might have a risk schedule and a budget reserve in case something happens that you hadn't planned for. A contingency reserve. If you knew the risk, let's say the risk was 20%, you could multiply 20% times the monetary effect of that risk and come up with a contingency budget that you'd add to the budget you had planned. You might have a contingency, it was 20%. Take the length of your project, multiply the time times 20%, add that to the time expected it takes your project to finish. And that's a contingency reserve for time. So you can plan for the time or extra undocumented or unplanned risks that occur. NASA does risk planning. They have contingency for what if the tiles fall off on the shuttle. They were doing that back in the day. They had, you have escape systems in the new SpaceX Dragon module that they've tested. So during launch and different periods during the launch, you could remove the manned portion of a payload. And all of these you put in an organizational behavior. You just have to plan and think of everything that could go wrong and realize there's more that could go wrong than you can plan for.